Hello everyone, I am Mr. Mohammed Hussein from Al-Noor International School, Grade 10 Geometry teacher. Welcome to week 11. Our this week lesson would be chapter 11, lesson 7, surface area and volume for similar solids. Here are the objectives of the lesson: to compare the areas and the volumes of similar solids, to find the areas and the volumes of similar solids, to tell the scale factors of the similar solids when their areas or volume is given. What are similar solids? Similar solids are 3D or 3-dimension shape that have the same shape and have all sides proportional. If two or more solids are similar, they should have the same shape and all sides must be proportional. Recall that in 2 dimensions similar figures, the ratio of the perimeters was equal to the scale factor, but the ratio of areas was the scale factor squared. Let me ask you a question. For a scale factor of A to B, what relationship do you think the surface area and the volume would have? Here is important theorem about the lesson. Theorem 11-12, areas and the volumes of similar solids. If the scale factor of two similar solids is A to B, then the ratio of their corresponding area is A squared to B squared. And the ratio of their volumes is A cubed to B cubed. A stands for the first dimension, it's the dimension of the first figure, and the B is the dimension of the second figure. After understanding the surface areas ratio and the volumes ratio, let's see some examples using the fact that the surface ratios is A squared to B squared and the volumes ratio is A cubed to B cubed. In this question, are the two rectangular prisms similar? If so, what is the scale factor of first figure to the second figure? In part A, as you can watch from the figure, the dimensions of the first figure is given as 332 and the second one 664. So let's compare the scale factor between the dimensions from first to second. It is 1 to 2 because 3 to 6 is 1 over 2 in simplest form. 2 to 4 is also 1 over 2 or 1 to 2. Then your answer will be yes for part A. What is your reason? Because the scale factor is 1 to 2. Let's go to part B. Again, put your concentration on the figures and its dimensions. The scale factor from the first to the second is not similar because the ratio of 3 to 6 is different from 2 to 3. For part C, two cylinders are given with different radius and different heights. Let us compare the radius from the second to the first one, usually from smaller figure to second figure. So it is 5 to 6. Then when you compare the heights ratio, it is 10 to 12, or in simplest form it is the same as 5 to 6. So your answer is yes, because the scale factor is 5 to 6. In this slide, we are going to verify if the two figures given are similar. First thing we have to concentrate on is the shape. Of course, the two figures have the same shape, but to say the two figures are similar, we need to verify the scale factor must be the same throughout. See the first figure, its length is 1 is 2 meter and its width 1 is 1 meter and its height is h1 3 meter. The second figure, its length is 4 meter and its width is 2 meter and its height is 6 meter. Then if you compare L1 to L2, what is the scale factor? It is 2 to 4 or 1 to 2 in simplest form. Again, compare W1 to W2, which is width 1 to width 2. It is 1 to 2, still the same as the first one, the same as L1 to L2. Again, compare the heights. H1 to H2 will be 3 to 6, which will be 1 to 2 in simplest form. Let us see example number 2. What is the scale factor between these two prisms? Which are the dimensions are not given, the volumes are given. So how are you going to tell if the two figures are similar? Easy. Remember theorem 1112. The volume ratio is the same as a cubed to b cubed, which means you can take the cube root of the quotient of these volumes to find the scale factor. So volume 1 is 729 centimeter cubed, volume 2 is 1331 centimeter cubed. So just by taking the quotient of the cube root of v1 to v2 will give you 9 to 11. Let us see example number 3. Find the scale factor and the ratio of surface area and volume. First of all, let us find the scale factor. You can use either the diameter or its height to find the scale factor. So let me use the heights first, from the second figure to the first one, from smaller to bigger one usually. It is 10 to 70 or 1 to 7, which is the same as a to 56 in simplest form is 1 to 7 if you take the diameter even. So the surface area ratios will be 1 to 49. How will get this one? Just by squaring the scale factor, because the surface area ratio is the same as the scale factor squared consecutively, and the volume ratios, or volume 1 to volume 2, is 1 to 343. Again, we obtain this by cubing 1 and 7. 1 cubed is 1, 7 cubed is 343. Let us see example number 4. Given the surface area and the volume of the smaller figure, as well as the scale factor, find the surface area and the volume for the larger figure. This question will be left as an assignment for you, but let me give you some clue. The scale factor is given 2 to 5, and the surface area of smaller figure is given to 320 miles squared, and the volume is 1920 miles cubed. So how are you going to find out the surface area 2? The surface area 1 to surface area 2 is equal to 2 squared over 5 squared, which is 4 over 25. Then 320, which is surface area 1 over surface area 2 is equal to 4 over 25. By cross product, you can find surface area 2. Likewise, volume 1 to volume 2 is equals to 2 cubed over 5 cubed, which is equals to 8 over 125, which means 1920 over V2 is equal to 8 over 125. By cross product, you can find V2. Finally, dear students, don't forget to practice all questions from textbook and workbook related to this lesson. Thank you.